Good morning, students. In the previous video session, we have discussed derivation and the combination of translation and rotational motion and about the rolling motion. And I believe that you all practiced that derivation. It is one of the important derivation, and we have to learn the sliding and slipping definition also. And today we can go through another important, very important 5-mark question, which is asked in the previous exam also. So this is one of the important derivation, very important derivation from this unit of rolling on inclined plane. So rolling on inclined plane, here you can see that the diagram. The inclined plane is there, just one object is rolling down. This is an inclined plane, and from this inclined plane one object is rolling down. Now you see, when this object is rolling down on an inclined plane, we can see two forces which is acting on this. Mg is a gravitational force and upward normal force. Here the component of force Mg can be split into what Mg sin theta and Mg cos theta. But the thing is, here you see this Mg cos theta and the normal force which is acting opposite to each other and cancelling each other. And Mg sin theta is what showing the translational motion. So translational motion means what? The object start to slide. So to avoid this sliding, there is a frictional force which is opposite to this. So the object can roll down easily. Now you see, you can write the translational motion first. For translational motion, you know this is the translational motion direction. This is what Mg sin theta. You can know that basic formula F is equal to Ma. From this F is equal to Ma formula, here you find the total force Mg sin theta downward. Upward what is there? Force. So opposite to Mg sin theta, force is there. So you can write that equation Mg sin theta minus F is equal to what? Now you see, this is for translational motion, and for rotational motion, what you can write down? Mg sin theta we can't use. But this frictional force provide a torque. So torque we can use here. So you know the torque formula down here. And we know torque is equal to I alpha. So use this torque equations, compare these two. So F is equal to I alpha. You know this I is equal to mk square. Alpha you can find out from the formula, angular acceleration R alpha. A is equal to R alpha. Alpha is equal to A by R. So this is the formula we are using to find out this. Now substitute R is equal to I mk square into alpha A by R. Take this R down, so F is equal to mk square into a by r square. Rearrange and write f is equal to mk k square by r square. mk k square by r square. Just rearrange and write down. This you keep equation 1. This you keep equation 2. Now substitute this f value in equation 1. So substitute 2 in equation 1. So you see mg sin theta minus, instead of f, this one, ma k square by r square equal to ma. Now ma, take it one side now. So mg sin theta equal to mk plus ma k square by r square. Now you can use small m. Now you see here ma, take ma commonly outside. So mg sin theta equal to ma taken outside. Inside what will be there? Plus k square by r square. M cancel. G sin theta equal to a into 1 plus by r square. From this you can find out the acceleration. So a is equal to g sin theta by 1 plus square by r square. This is, you can keep equation 3. So we got the acceleration, we got the force, and we got the acceleration. Now we have to find out the velocity. So while find out this velocity, we can use the equation v square is equal to u square plus 2as. Because it is moving in an inclined plane, so there must be some height here. So we can use this formula. So this object start moving from rest. So u will be 0 and s, the displacement of s will be what? S by sin theta. This is a formula s by sin theta. Now apply this formula. V square is equal to 0 plus 2 into a. A means this one. G sin theta by 1 plus k square by r square into s by sin theta. Now sin theta cancel. So v square is equal to 2gs by 1 plus k square by r square. Now v you can find out. V is equal to root of 2gs by 1 plus k square by r square. Okay. Now you got the velocity. Keep this as equation 4. Now we are going to find out the time taken for this object to rolling down. Now we are going to find what? The time taken for this object to rolling down. For that we can use the formula v equal to u plus at, and here The initial velocity u is equal to what? 0 only. So v equal to at. T is equal to what will come? T is equal to v by a. T is equal to v by a. So substitute this v value and the a value from equation 4 and 3. This you can keep equation 5. Substitute 3 and 4 in equation 5. Now you see T is equal to V value. V value is what now? T is equal to root 2Gh by 1 plus K square by R square divided by what out? A value. A value is G sin theta by 1 plus K square by R square. Now take this denominator part upside down, so it will go what out? Change the root 2Gh divided by 1 plus K square by R square into, take this upside down, 1 plus K square by R square divided by G sin theta. Now you see here root 1 plus K square by R square, here 1 plus K square by R square. So we can cancel this if there is a root here. So we can bring the root here. You know this root 2 into root 2 is what? 2. So you can write this 2 times with the root like this. T is equal to root 2Gh by root of 1 plus K square by R square into, this you write 2 times, root of 1 plus K square by R square by G sin theta into root G sin theta into 1 plus K square by R square divided by root G sin theta. Now you can cancel this. So what is remaining? So you see here G is a root G, root G, root G. Take this G outside up. So T is equal to root G into root 2H into what are? Root of 1 plus K square by R square divided by what are? Root of G into root of G into what are? Root G sin square theta. So here one root G is there. We need to cancel this root G. So I have taken this root G outside. Like that from here also root G I have taken outside. So inside sin into sin what are? Sin into sin is sin square theta. So you can cancel this root G. Now T is equal to root, you can write it all same on root of 2H 1 plus K square by R square the whole divided by root G sin square So this is what the time taken for the object to roll down. So this is one of the important 5-mark question we can see. So first what we have to do, we can find out now for translational motion. You have to remember the diagram. So you remember this thing on the object which is rolling down on an inclined plane. The forces which is acting mg sin theta to balance this water. There is a frictional force which is opposite to that. So for translational motion, you can write the equation what mg sin theta minus f is equal to ma. And for rotational motion, we can't use this mg sin theta. So we are using the torque equation, and you know this frictional force is providing the torque. So torque equation is Rf and I alpha. So compare these two equations. Rf is equal to I alpha. You can find out. You know that I is equal to mk square and alpha is equal to. We can find out from A is equal to R alpha. Alpha is equal to A by R. Now substitute this I value and alpha value here. So Rf is equal to mk square into A by R. From this we can find out here. R will come here, so R into R square, so we can find out the F. Now substitute this F value in this equation 1. So mg sin theta minus ma k square by R square is equal to ma. Take this ma outside. So what will come? Mg sin theta is equal to ma plus ma into k square by R square. Now take this ma outside. So ma taking outside means here what will come here? K square by R square. So ma cancel g sin theta is equal to what? A into 1 plus k square. Now find out the acceleration g sin theta. You take this part down 1 plus k square by R square. Now you can find out the velocity of this object to roll down. V square is equal to u square plus 2a is formula you can use, and here the u value is 0. And here it is moving in an inclined plane, so s is equal to h by sin theta. You can use the formula, substitute here. Now what will come? Now you see this h by sin theta is there, sin theta is getting cancelled. Now 2gh 1 plus k square by r square. From this you can find out the v. So v square is equal to this one means v means v is equal to root 2gh divided by this one. Now you can find out the, so we got the velocity. Now we have to find out the time taken for this object to roll down. So that we can use the formula v is equal to u plus a, and here also initial velocity is 0, u equal to 0. So time taken t is equal to v by a. Substitute this v value and a value in this equation. So substitute that here. Now take this upside down. So denominator will come up and the numerator will come down. Now for our cancellation we are using this. Root 2 into root 2 means 2. So like that we are writing this 2 times with the root. Now cancelling this and this. Here g is root g. We can cancel. So next step I am taking outside and cancelling, remaining writing it. This is one of the very important question you have to learn. So unit 5 also finished. Unit 5 finished means our first volume book finished. In this you can see the long answer question. The first question is, you can take page number 262. Explain the types of equilibrium with suitable examples. You can use the page number 228. Answer is there in the page number 228. And next one is, explain the method to find the center of gravity of an irregular shaped object. You can refer the page 231 and 232. Next question, bending of a cyclist. Arrive at the expression for angle of bending for a given velocity, page number 232 and 233. Next question is about the moment of inertia of rod, page number 234 and 235. Question number 5, moment of inertia of a uniform ring, page number 236. Question number 6, expression for moment of inertia of uniform disc, page number 236 and 237. Then conservation of angular momentum with example, page number 234. Question number 8, parallel axis theorem, page number 239 and 240. And perpendicular axis theorem, 240 and 241, page number. Then drawing on an inclined plane, this derivation, page number 256 and 257. Out of all these 10 questions, very important question is question number 1, types of equilibrium. Question number 3, bending of cyclist. Question number 4, question number 5, question number 6, moment of inertia of uniform rod, uniform ring, uniform disc. Then parallel axis theorem, perpendicular axis theorem, this derivation. Rolling on inclined plane. If you are studying this 8 question, surely you will get one 5 mark and one 5 mark question. Surely you will get from this unit. And see you all with our volume 2 book. Bye bye. Thank you.